right, so we start out with a system, 20C plus 10M equals 495, because they bought 20 calculators and 10 measuring tapes for the classroom and spent $495. However, you'll notice that Desmos doesn't exactly know what to do with that. So I'm going to change my C to X and my 10 to Y. I'm going to say that my calculators are my X-axis, and my measuring tapes are my Y-axis. That way it knows how to graph the line. We can do that as well with 8x plus y equals 178.50. Nice. And we see that solution that was on the earlier slide, that 21.5 and 6.5. Right, so that would mean that she buys 21.5 calculators and 6.5 measuring tapes. All right, let's talk about this one. So we start with the equation 20C plus 10M equals 495, where C is the cost of the calculators and 10 is the cost of the measuring tapes, because the teacher buys 20 calculators and 10 measuring tapes and it costs $495. Desmos doesn't know what to do with this equation because it doesn't have X and Y. So instead of using C and M, we're just going to switch it out for X and Y. That's totally okay. You can do that anytime you need to. It's a little bit bigger, so I have to zoom out a bit to see the line. Okay, the other one says 8x plus, so 8 calculators and 1 measuring tape that she orders later. She spends $178.50. Right? So my x-axis is the cost of the calculators. My y-axis is the cost of the measuring tape. And we see here clearly 21.5 and 6.5. And you might be thinking, wait, I can't have half of a calculator. Well, that's true, but this is the cost of the calculators, right? So what makes sense in this scenario is that the calculators cost $21.50. The measuring tapes cost $6.50. Okay, so the teacher has to submit a receipt for reimbursement and actually says, okay, in total, I bought 20 calculators the first time and 8 the second time, so I bought 28 calculators. Bought 10 measuring tapes the first time and 1 the second time, so about 11 total. And then the total cost here, when I add those together, is $673.50. So this is actually the receipt that she submits for reimbursement. And what we notice is that it also goes right through the solution point, which makes sense, right? Because it's not like the calculators and the measuring tapes started costing something different just because we're totaling the whole thing together. So how many possible solutions does this have? That's what D is saying. Really, there's only one, right? There's only going to be one cost for the calculators and the measuring tapes. They're not going to change in cost. Otherwise, you know, this would be a much more complicated problem if they were changing all the time. And so adding them together, this is now talking about her total. What's interesting, though, is by adding them, we didn't eliminate one of the variables. So we didn't make it easier to solve here. However, it does still go through that same point. So it's still valid for finding the solution. We just may need to be more strategic with this one, because if we add it together, or even if we subtract it, like if I do 20 minus 8, that's 12x, 10y minus 1y is 9y, and then 495, hold on, you gotta give me a second here, minus 178.5 and 1650. Okay, again, goes through the same point, but doesn't really help me get rid of the x or the y. And that's what this lesson is going to be all about. How do we more strategically add and subtract equations so that we get either that horizontal or vertical line and eliminate x or y?